So good afternoon, friends. Let us start our discussion for practicals which you have to perform. So please make a note. You note down in your copy the first four practicals which you have to perform. They are the simulation practicals. So simulation. So you have to solve the particular problem analytically, as well as you have to simulate it in the softwares which we'll discuss just after this, and then you have to submit, you have to save it in a short link. You can make a short link for that and you can submit all the four practicals. Okay, so based on all this submission will be your marks. So your entire marks will be based on the submissions which you will be doing. So be regular and punctual for submitting the things. So first practical which you have to perform is determine the following. I have shared the screen. Is the screen visible to everybody?
Yes, sir.
Yes, sir.
So first experiment is determine the following using KVL, KCL, node analysis and mesh analysis. Okay. So first is current through various given branches, voltage across the given branches and power absorbed or delivered by the given component. Analysis of simple DC circuit using all above techniques. So till this is your first practical. So what you have to do? You have to verify Kirchhoff's voltage law, Kirchhoff's current law, node analysis and mesh analysis. So you have to solve, you have to take four problems at least, one for each, one for KVL, one for KCL, one for node analysis and one for mesh analysis. For mesh analysis, you can take more problems even. All four types we have seen. Type 1 problem, type 2 problem, type 3 problem and type 4 problem. In type 1, independent voltage source and resistances are there. In type 2, along with voltage source, current source will be there. But the current source will be outer side of the loop. Means it is current source is not common between any two branches. So that is type 2 problem. Then type 3 problem is the network is containing dependent sources. Dependent sources may be dependent voltage source, dependent current source. It may be voltage dependent voltage source or current dependent voltage source. Or it may be voltage dependent current source or current dependent current source. So out of these, anything will be there. So this is type 3. In type 4, current source is present, independent current source, but that current source is common between the two meshes. So that is type 4 problem. Now there may be combination of type 2 or 3 problem, maybe type 2 or 4 problem. These problems are there. So in theory lecture, we'll see all these problems, but in practical, you have to solve at least one case for one type for mesh analysis. So 4 problems on mesh analysis, 1 problem on node analysis, 1 for KVL and 1 for KCL. So in all you have to solve 4, 1, 5, 6 and 7. 7 problems you can solve for this first assignment or first practical. And in that case, what is this given? Current through various branches or voltage across the branch or power absorbed. So that is, you can find current through any particular component. Or you can find drop across that particular component. How to find drop across that component? I into R. Current value you have found out. So that current into the value of resistance will be voltage across that particular branch. And if you want to find power absorbed, then how to calculate power? Power is calculated as I square R. Current value you have already calculated. So you calculate I square R. So that will be power absorbed or delivered by that particular component. So these you can find out after you will find the value of current. So you simulate all these, and then for second practical, it will be determine the following using network theorems. So one problem statement on each theorem means you have to solve. We are having 4 theorems in our syllabus: Thevenin's theorem, Norton's theorem, superposition theorem, and maximum power transfer theorem. So based on each theorem, you have to solve one numerical. You solve it analytically, and then you have to simulate it. Again, you can find current through that component, voltage across component, or power absorbed or delivered by that component. So 4 theorems, 4 problems in this second assignment. So second practical and first practical, is it clear to you? And you have to take the problems which I have not solved in the class, or I have not given you the short link of which. Okay, because the problems which I have solved in the class, for them I have created a short link. I have developed a circuit in simulation circuit software, applet, and that link I have provided it to you. So those problems you will not solve because they already have solved them and I have provided it to you. So you have to solve new problems so that your practice of solving the problems will take place. Okay, so for that purpose I have kept this condition. And one thing, your problems should not be same. Okay, so roll number 1 will not solve the same problem as roll number 2 or roll number 3 or roll number 4. So you try to solve different problems. Okay, that means the aim is not to copy. So please don't copy. If you have not understood anything, you can clearly ask me, directly ask me, either in the class, or you can drop me a message on the WhatsApp group. I'll repeat that, or I can take extra class for those who have not understood the things. Okay? Is it clear? The next third practical is
Yes, sir.
carry out the transient analysis and determine the voltage or current expressions for the given network involving RL, RC, and RLC. So this for RL, RC, and RLC, I have already provided the videos to you. In that, this transient analysis is carried out. The voltage and current expressions are calculated, so that you can see, you go through those videos and then try to implement, try to simulate the circuits with the various values of R, L, and C. You can assume the value of resistance, inductance, and capacitance, and voltage even, voltage source or current source. You can assume the certain values, and for those values, whatever may be the response, transient analysis you will get, you have to draw that. You have to simulate that. And after simulation, you send the link to me, and again you have to solve the same problem analytically. You have to solve the problem analytically and try to verify it with the software, simulation software. And last, fourth practical is determine Z, Y, H, and ABCD parameters for given networks. So 2 networks I have given to you. One is T network and another is pi network. For this T and pi network, you have to find Z parameter, Y parameter, H parameter, and ABCD parameters. So for all these parameters, how to calculate those parameters, The videos I have already provided it to you. So you can go through those videos, and in all these parameters, there is nothing special. Either you have to calculate short circuit voltage or current, or open circuit voltage or current. So for all the parameters, you will either have to short circuit the output side and measure it at input side and output side. What is V1, I1, V2, I2. So all these parameters you have to measure by shorting either output side or input side, or keep open circuited output or input. So depending on the definitions, you can find out the value of Z11, Z12, Z21 and Z22. Similarly, Y11, Y12, Y21 and Y22. Similarly, H and ABCD. So all these parameters you can find out. So please note this circuit diagram. It is a T network having 20 ohm resistance and 30 ohm resistance at the top side, and on the bottom arm there is 40 ohm resistance. You can change the resistances values and you can simulate. That is not an issue. So for every experiment you can change the values, or rather I'll expect that every roll number will assume his or her own values of resistances and voltages and currents. Okay, but the network will be similar. It is T network, so T of a resistance. So one resistance over here, another resistance over here, and third resistance is here. So it is forming a T, English letter T. And next is this pi. So this pi network is, here is one resistance and here are the two resistances. So I have given here one resistance value as 5 ohm. Here it has 20 ohm and here it has 15 ohm. So 5, 20 and 15 ohm. This is for just an example. You can take any values of voltage, current if required, and the values of resistances. You change all the values and find out all the parameters Z, Y, H and ABCD. Here also, in this experiment also, you have to calculate it analytically. The method which is explained in that video, either you calculate it by that method or any of the method which you will find easy to calculate. So calculate it analytically and you have to verify it using this simulation. So understood all this? Yes?
Yes, sir.
So I have stopped sharing that screen. Now I will share another screen and we'll see the simulation softwares, both the softwares which I have already told you. One is Tinkercad and another is our Falstad. So in falstad.com/circuit, so is it visible on your screen?
Yes, sir.
So in this, first what you have to do, I'll just repeat it because I am recording this for benefit of those who cannot get the link right now. They can observe it later on also. Okay. So what you have to do first, in circuits, you have to find a blank circuit. So a blank screen will be available on your screen, and on this blank screen, now you can go in draw, then you can add resistor. Going in this, you can add resistor like this, or like this, You can go on adding n number of resistances. If you want to change its value of any component, double click on that. The window will appear where you can change the value of that particular component. So since this is a resistance, you can change its value. You can keep it as any value which you want. If you want it at 100 ohms, I'll make it as 100, apply and OK. So 100 will appear over here. If you want to change this, let us say in kilo ohms, say 100 kilo ohms, then you write 100K, then apply and OK. So it will be 100 kilo ohms resistance. So you can add resistance by drawing, go in draw, add resistor. So you can add resistance. If you want to make wire connections, go in this draw, add wire, so that after adding wire, you can go on adding wire. You can draw wire like this. You can draw it like this, any shape of this wire, any type of connection which you want, you can go, you can stop there, you can go further, you can stop, you can start here, you can move further, you can stop, you can join this terminal, then you can start it again from this, you can move here, you can join this terminal, then you can move here, you can go. Like this, you can draw wires. Then, if you want to add passive components in it. So, passive components means if you want to add a capacitor, inductor, add switch, push switch, SPDT switch. So, these switches you will require in transient analysis, single pole double throw or push switch, then potentiometer if you want, transformer if you want, relay if you want, you can add these passive components from this link. If you want to add inputs and sources, you go in this, you can add a ground, you can add a voltage source, 2 terminal, you can add AC voltage source, 2 terminal, one terminal voltage source, AC voltage source, 1 terminal, square waveform source, that is your function generator. You can add a clock, sweep, and so on. AM source, FM source, current source. If you want to add current source, you can go here. I'll click this, and you can add here current source. So you can draw current source like this or like this. You can double click on that. If you want to change its value, you change it. If you want it as 5 ampere, make it 5, apply and OK. So it will become a 5 ampere current source. If you want to change this as, let us say 10 ampere source, or in milliampere also you can write 10 ampere source, then this will be a 10 ampere source. Okay. If you want to add, let us say voltage sources, because these sources you will require, that's why I am drawing this. If you want is a voltage source, DC voltage source, 2 terminal, you can draw it like this, you can take it, it will be having negative and positive polarity. If you will take it like this, it will be positive and negative polarity. If you want to change this voltage, again double click on this. This is a 5 volt. You can change it to any voltage. If you want to make it as 25 volts, right here 25, it is waveform DC voltage, offset is 0, then apply and OK. So this will become a 25 volt source. Now there is no caption over here. So voltage is not displayed on this. So if you want to display this 25 volts, you keep it on the keep the cursor on that component. You will find that here the voltage reading is there. Okay, so the voltage reading is 25 volt. But if you want to write it here in the diagram, then what you have to do? You have to add labels. So here outputs and labels. You go in this and you will find here add a text. So go in this. You can add here a text. hello word will appear. You double click on this so that you can, instead of this hello word, you can replace it as 25 volt. So that apply and OK. So it will be there. Okay, so 25 volt is displayed. If you want to change voltage of this, again double click on that. You can change the voltage. Any voltage you can keep 100 volts if you want. You write it 100, apply and OK, so that it will be 100 volts supply. If you want to display it like this, you can copy this link, write it here, again change that, or you can add label, drawing it from inputs and labels. Okay, outputs and labels. Then if you want to measure current or voltage, if you want to measure voltage, you have to add voltmeter across that particular component. So here you can take add voltmeter. If you want to measure voltage across this resistance, say, so I'll draw it here. So positive of this terminal voltmeter is at upper side and negative on lower side. Then you have to join this using add wire. So draw wires in such a way that it will be connected across this particular resistance, so that the voltage reading across this resistance will appear across this particular voltmeter. If you want to draw ammeter, if you want to measure current through any component, then go in outputs and labels. Here is add ammeter. So you add one ammeter, you can add it anywhere. If you want it to add in this loop, you add it here. If you want to add it here, you can add it here. Now I'll delete this particular link and then I'll insert it here. I'll insert this. I have to escape first, escape, and then I'll move this component here. Then I have to make connection of this. I have made it connection here. This current source, I have to insert it here, let us say. So I'll delete this link and I'll insert this current source here. And here, if red dot is occurring, that means some wrong connection is there. And you will find the message at the bottom here, one bad connection. So one bad connection means at one point I have missed the connection and it is indicated by this red dot. So if red dot is there, you find that and make the connection. Now that bad connection, it has removed from this particular point. Okay, that means I have connected, or I have made all the good connections here. Okay, so I hope we have completed all these outputs and labels. One more, active components you will, not active components, active building blocks you will require. That is the dependent sources. If you want to build dependent voltage source, it may be voltage controlled voltage source or current controlled voltage source, or it may be voltage controlled voltage source or current controlled current source. That is the dependent sources. So if you want to make connections of dependent sources, go in this active building blocks. In active building blocks, you will find all these: add voltage controlled voltage source, add voltage controlled current source, add current controlled voltage source, and add current controlled current source. So you can click on any one of this and you will find that it is appearing over here. Now this is these two terminals are the particular points where you have to take the sample. That means if it is voltage dependent voltage source, then this A and B will be the points from where you will take the sample of voltage. Okay, it may be V1, V2. So these connections you have to do. If it is current controlled, then you have to make this in series. So this should be series connection so that current will flow through this AB terminal. So whatever may be the controlling parameter, that will be applied to this A and B terminal. And in your diamond shape, that diamond shape will be here V plus and V minus. So V plus indicates your, this is a voltage source. So positive of this voltage source you will connect it to this, and negative of voltage source you will connect to this. Is it clear? So I hope we have completed it for our purpose. So for all the practicals, first 4 practicals, you will require this much only. And for second, you will require the switches. So that you can take it from this push switch or SPDT, DPDT like this. So it is a single pole double throw, single pole single throw like this. So this switch position you can change, right? Like this. At t equal to 0, it is at this particular position. At t equal to 0, t equal to, let us say 0, we have changed it. Or at t is equal to infinite, we have changed this switch. So for this purpose, such switch will be required. So I hope we have completed almost all the parameters which we require, all the elements or components we require for building our circuits. So in falstack.com/circuit, we have completed it. Now in a quick time, we'll go to this Tinkercad. So it is Autodesk Tinkercad. So you can write, is it visible to you? Tinkercad?
Yes, sir.
Tinkercad dashboard. So Autodesk Tinkercad is there. So 3D design, circuits, then code books, lessons. So we are interested in circuits. So go on circuits. If you will go on circuits, it will give me create new circuit. So I'll have to start with create new circuit. And if I have created it earlier, those will be available in my this window. So here will be n number of circuits. If you will create it, they will be available all the time. Once you will create it, it will be available for lifelong in your login. So you have to log in first in this Autodesk Tinkercad. You can log in with your Google login, Gmail login, and then you have to enter in that. I have entered it through my login, so it is seen that Pradeep Patil. So this is my login. So you have to create your own login. It is free of cost. So you create it for you and go on create new circuit. So if you will go on create new circuit, one blank screen will be available to you. And on that, on right side, all the components are there. You can pull these components, register if you want. You can take it, you bring it here. Then automatically what name you have to write, you can write here. Let us say it is R1 resistance. What is the value of resistance you want? Let us say it is 5 ohms. It is kilo ohms it is showing. So you have to change it to ohm. You can take it as milli ohm, micro ohm and all. So all the values, mega ohm, giga ohm, all values are available. You select particular value and leave it. So automatically the code will be available, color code will be available. If you want to check its value, you can check it again. Okay. If you want to rotate this particular component on this side, extreme left side, where the Tinkercad is written, here is the rotate option. Can you see this? Rotate option. Yes.
Yes, sir.
So you click on that, click on that, click on that. So as you will be going on clicking on that, this component will rotate. So you can keep it as you want. You can rotate it. Okay. Then one facility is there. If you want to search any component in this, you can go in search. If you want a voltage source, you write here voltage source. So this voltage source, immediately voltage 9-volt battery is there. So you can name it. You can change the voltage if you want. If you want a voltage source as that of in laboratory, that also is available. You write here power supply. So you will get a variable supply. Power supply. So power supply, you will get this is power supply which we are using in laboratory. Okay. Voltage you can adjust, current you can adjust, and name you can write. So here you can take any variable voltage, let us say 13 volt. The 13 volt voltage will be there. Okay. So these are the two terminals. One is positive. If you will go on this, it will be a positive terminal. If you will go on this, it is displaying negative terminal. So positive and negative. And for drawing wires, you can simply take from that particular terminal and you can move. No need to take any wire from anywhere, and you can go to that particular terminal and you have to end it, finish it. If you want to change color of that wire, you can change it to any one, black, red, orange, yellow, green, any, let us say blue. So it will be blue wire. If you want, you can start from this terminal. You can take a wire, you can draw it like this, any type. If you are taking like this or crossing over, there is no connection. If you want to connect it, you have to make the connection. Otherwise, this cross wire will not have any connection. So I have to leave it here. So these points are the points where I can make connection of any wire. So I can make connection from this if you want, but it is same. So if you want any other wire to connect it over here, you have to connect it over here, these points. Okay. Then you can change color of this also to any one, orange say, like this. Then you can take meters, voltmeter, ammeter, whatever you want, you can take from this. So you can write ammeter. What will happen? Ammeter, it is current meter, it may be. I have to find the list again then. Battery. If you want breadboard, breadboard is also there. You can take this breadboard here. Breadboard is there and you can make connections and so on and so forth. So I hope you say this multimeter is there. So you can take multimeter. On this multimeter, you can change the mode if you want to measure voltage. Voltmeter if you want to make use of it. So keep it here voltage. If you want to measure current, you can write here amperage, so that now it will function as ammeter, and here you can see it has moved to A. So it is ammeter, working as ammeter. Then if I'll keep it as voltage, this dot has shifted to this point, so it is acting as voltmeter. If I want to measure resistance, I'll make it as resistance meter. So this is a ohm meter now. So you can connect this power supply, meter, resistances. That's all. Again, dependent sources. So dependent sources are also present. You can go in that, search and find out the dependent sources. Independent sources I have shown, and you can simulate either in this platform tinkercad.com or that circuit simulator applet which fullstack.com. So you can simulate in any of these two and find out is it okay? Yes.
Yes, sir.
So if any difficulty or doubt is there, you can ask me directly. And if not, what should be the last date for submission? How much time you will take? Yes. I'm recording the session. I'll stop it first.